So it's topic 2, kinematics, right?
Yes, sir.
You can see the screen.
Yes, sir.
Okay, so here we have speed, velocity, acceleration. Beside it also we brought distance and displacement, because to understand speed and velocity we need to understand distance and displacement first.
Yes, sir.
Uh, Here I gave one example. Distance and displacement, you can understand it from the diagram, right? Easily.
Yes, sir.
And there are some differences between distance and displacement.
Yes, sir.
Can you read the differences?
Uh, Distance and displacement. Number one,
Yeah, continue.
distance is the length of the path traveled by a body while moving from an initial position to a final position. Displacement is the shortest distance between the initial position and the final position of the body.
So it's clear, right?
Yes, sir.
Continue then.
Distance is a scalar quantity. Displacement is a vector quantity. Distance measured is always positive. Displacement can be positive or negative depending on the reference point. The total distance covered is equal to the algebraic sum of all the distances traveled in different directions. The net displacement is the vector sum of the individual displacements in different directions. There is always a distance covered whenever there is a motion. Displacement will be zero if the body comes back to the initial position.
So all are clear, right?
Yes, sir.
Now speed and velocity. Here we have the formula, right? Speed and average speed.
Yes, sir.
You should remember this one. Then speed is scalar, velocity is vector quantity. Uh, then we have here examples, how speed and velocity is different.
Yes, sir.
Okay, then acceleration, right?
Yes, sir.
Acceleration formula. Can you read the formula of acceleration?
A equals to v minus u by t.
And the SI unit of acceleration is?
Meter per second square.
Okay, then this one. Read the fourth one.
If the velocity of an object increases, the object is undergoing acceleration. Hence, if the velocity of an object decreases, it is undergoing deceleration. So deceleration is negative acceleration.
So here we got deceleration, which is negative acceleration when the velocity decreases, right? We got
Yes, sir.
deceleration or retardation. It's also known as retardation. Some of the places in questions you will get that the car slows down or car retards this way, right? That is also
Yes, sir.
deceleration. Then continue.
If the velocity of an object is constant, the acceleration is zero.
Very important, very important. If the velocity does not change, that means it remains
Yes,
same,
sir.
then there will be no acceleration, because acceleration relates velocity change, right?
Yes, sir.
Then continue.
An object is said to be undergoing uniform acceleration when there is a constant increase in velocity per unit time.
Okay, so uniform means same acceleration, right?
Yes, sir.
That means rate of increase of velocity remains same. That time we are saying it uniform acceleration. And non-uniform means the rate of increase of velocity changes, right?
Yes, sir.
That one. So here we got one example of graph, distance time graphs. Okay, so here we got stationary. That means distance, time is going, but the distance remains same, right? Then
Yes,
the
sir.
object is stopped or stationary or at rest. Then it's slowing down or deceleration. Yeah, here we got this curve. Curve is going this way. Its uh, gradient is decreasing the rate, right?
Yes, sir.
That one is slowing down. And then here we got acceleration is for distance time graph. Okay, there is curve line, there is
Yes,
acceleration.
sir.
But if it is steeper straight line, then it is constant speed. Okay, here we got some features for distance time graphs. Whatever we are seeing in the graph, that one is described here. Then here we got separately distance time graphs. Uh, Here I gave this for some reasons to understand that uh, both are constant speed. These two diagrams, both are constant speed, but one is with more speed, another one is less speed, right?
Yes, sir.
So uh, how we understand it? If the line is more steeper with more greater positive gradient, then there is uh, more speed, right, in distance time
Yes, sir.
graphs. Here the gradient is less, it is less steeper, so it's less constant speed, right,
Yes, sir.
or smaller constant speed. And this one is stationary, right?
Yes, sir.
Here we say speed is zero, or the object is stopped, object is at rest. Now we got the comparison of constant speed. This one is slow, this one is fast. In the same diagram, we can show that, right?
Yes, sir.
Then displacement time graphs almost similar. One minor difference. Can you read this?
There is a straight line with a negative gradient. It means that the object is traveling at uniform velocity in the opposite direction.
So if the object is returning back, right? In
Yes,
that
sir.
time we are seeing their negative gradient in displacement, right?
Yes, sir.
Then velocity time graphs. Here we got uh, velocity time graphs. What students do, they mix up with velocity time and distance time graphs. So you, before you take the decision for any of the questions, you first think that is it distance time graph or speed time graph or velocity time graph. Then you choose your option or do your calculation. Clear to you? So
Yes, sir.
here it is velocity time graph. If the object is rest, then the line will go with time axis, right? That means
Yes, sir.
the velocity is zero. Then we have the second one, uniform velocity. In distance time graph for uniform velocity, we got this way, right? From origin
Yes,
to
sir.
upwards. But here we are getting uh, uh, horizontal line to time axis. Then constant acceleration. In distance time graph, we got for constant acceleration curved line. For velocity time graph, constant acceleration is steeper straight line. Okay.
Yes,
Then
sir.
constant deceleration, we are getting negative gradient. And finally, we are getting non-uniform acceleration, non-uniform deceleration. Okay,
Yes, sir.
here we got non-uniform acceleration. This is also acceleration. That means here we are getting some increase in velocity, right? With time.
Yes, sir.
Also here we are getting acceleration. And it is curved line, non-uniform. If it is uniform, then constant acceleration. Okay, straight line.
Yes, sir.
So all these things are described here. And finally, there is one point given here. Can you read it?
The area under the graph is the change in the displacement of the object.
So if you take the area under the graph, then is giving displacement, right?
Yes, sir.
Uh, you see here we got all these things together. Hmm. Can you read all this labeled? Hmm.
Sloped upwards gradient shows acceleration.
Mhm.
Steeper gradient shows quicker acceleration.
Mhm.
Horizontal line shows constant speed.
Mhm.
Slope downwards gradient shows constant deceleration.
Yeah, the middle one.
Total area under the graph represents displacement.
So if they ask you that how much distance or displacement travel, then you have to calculate the area under the graph, right?
Yes,
And
sir.
here we got another point that if previously we got for uh, distance time graph, we got that if the line is more steeper, then there that is greater constant speed, right?
Yes, sir.
Here we got velocity time graph. This one is less steeper, and next to this one, it is greater, right?
Yes, sir.
More steeper. So if it is more steeper, then this one is greater acceleration, right?
Yes, sir.
So for velocity time graph, steeper, more steeper the graph, greater the acceleration. Clear now?
Yes, sir.
And here we got one calculations how to get the area under the graph. Look, here we got in 5 seconds the speed of the object. It is 50 meter per second, right?
Yes, sir.
And you are seeing one shaded area. This one is giving the distance traveled. For this, we are doing the formula of area of triangle. As we got here, area under the graph is triangle. So the formula is half base height, right? Half into base
Yes,
into
sir.
height. Your base is here 5 seconds, and the height is 50 meter per second. If you calculate, it will come 125 meter. That is distance traveled. Clear to you?
Yes, sir.
Similar way, we are getting more, uh, you know, examples here. Now here we will calculate. Can you work on your copy? This one is page number 8. Okay, page
Yes, sir.
number 8. You write that working the first one and how to get all this. Hmm. Here, can you find how much distance is traveled for the whole journey. This one.
Yes, sir.
For for A, there is acceleration. How much distance is traveled? It is triangle, right?
Yes, sir.
So what will be the formula? Half into base into height. Then what is the answer?
100.
100. Very good. So here for A it is 100, right?
100. Yes, sir.
For B how it is? It is rectangle, right?
Yes, sir.
So what is the formula of rectangle?
Uh,
Rectangle area is length into breadth, right?
yes, sir.
So what is your length? What is your breadth?
Uh, Length is uh, 20,
Hmm.
and breadth is also 20.
Very good. So how much it comes? 400.
Yes, sir.
400 meter. Then for C, part C,
Uh, 70.
is it 70?
Yes, sir.
How? It is half into base into height, right?
Yes, sir.
So how much is your base?
Base 0.
No, base is 40, right? From 30 to 70. How much?
40.
40. Half into 40, that means 20, right?
Yes, sir.
Then we are getting height same, 20. And how much
Yes,
it
sir.
comes?
400.
400. So you got at the beginning you got 100, then 400, again 400. So
400.
how much total distance traveled?
600.
600 or
No,
more?
900. 900.
900, 900. Then what is the average speed of the whole journey?
300.
How?
Uh,
What is the formula of
one.
average speed?
We should divide it by 3.
Yeah, the total distance you should divide by t. What is the value of t here?
Uh,
T means total time, right?
yes, sir.
So what is coming? Total time is how much? 70, right?
Yes, sir.
So total distance traveled, how much you got?
Total distance 900.
So 900 by 70, right?
Yes, sir.
So how much it comes?
12.85.
12.85, right?
Yes,
So
sir.
uh, you see how you have to use this, right? The formula.
Yes, sir.
The formula for average speed you understood here, and how to calculate the area under the graph you understood here, right? Now
Yes,
it's
sir.
your work. You will do it and tell me the answers for 1, 2, 3, 4. Can you tell me the answers?
Yes, sir. A is 900.
No, I'm asking this one. One. Can you read the question?
Match match the journey phase with its line on the graph.
Hmm. So which line is showing this one? First line, second line, or third line?
First line.
Decreases speed.
Decreases speed is the third line.
Yeah, decreases speed to approach the next station is this one, right?
Yes, sir.
So the second one,
Second one is the first line.
departs the station and increases speed. Okay, very good. Increases speed for 30 seconds. Okay. Then travels at a
Uh,
constant speed. It is the second one,
the
right?
second line.
Yeah. Then two. What is the answer of two? Find the
900.
acceleration. How will get the acceleration? What is the formula of
Uh,
acceleration?
V minus U by T.
So you got your v. Here you got the value of v. V is your final speed, right?
Yes, sir.
So what is the value of final speed? Are you doing this in your copy? Please do it.
Yes, sir.
Then
60.
it's helping you. Yeah. V is 60, right?
Yes, sir.
60 meter per second. And U is 0. You
U is
started
0.
from 0.
Uh,
Then your time is
30.
30. Then what is the acceleration?
2.
2. If you say only 2, is it okay?
2 meter per second square.
Very good. Then continue. 3. 3. How to do 3?
Sir, I cannot do it.
Find the retardation over the final 70 seconds. So it's from here 80 to 140. Is it 70 or 60?
60.
So you correct it, huh? It should be 60. 60
Okay, sir.
seconds. So it is find the retardation. Retardation is slowing down. Our slowing down is happening here, right? Here you got
Yes, sir.
decreases speed. So you already understood this is decreasing speed, right? And I already told you that retardation also means slowing down or deceleration or decreasing the speed. Similar thing, right? Retardation.
Yes, sir.
So the same formula we will use for getting retardation. The one we use for acceleration. V minus U by T, right?
Yes, sir.
So you got here V, your V
V
is
will
how much
be.
here? 60. No, no,
Yes,
your
sir.
U is 60 here.
U is
And
sixty.
V is here final, right? Because
Yes,
you
sir.
started here and you finished here. So your U is here 60 and V is here 0. So 0 minus 60, right?
Yes, sir.
Divided by 60. Your time is 60, right?
Yes, sir.
Then how much it comes? Minus 1.
Yes, sir.
Minus 1
Minus 1.
meter per second square, right?
Yes, sir.
This way we can find. So is it clear to you now?
Yes, sir. Clear.
Now find the total distance traveled. You can find it, right?
Yes, sir.
The way we did before, like this one is one triangle. We can find the area under the graph. Then another triangle and then rectangle from here to here. We can find. Then another one, the final triangle we can find. Then add them together to get the total distance. Or you can do shortcut using the formula of trapezium, right? To find the
Yes,
total
sir.
distance. Can you remember that one? Formula of trapezium.
No, sir.
Okay, you write in your copy this one. Uh, trapezium area, huh?
Yes, sir.
What is the formula? Half multiplied base multiplied height, right?
Yes, sir.
Or different? You forgot. A plus B. It is trapezium, right?
Yes, sir.
It's not triangle. So you should use this formula. Half into A plus B into H, right?
Yes, sir.
Okay, now A plus B are the two sides which are parallel, right? This and
Yes,
this.
sir.
One is A, another one is B. And the height is the distance between these two parallel sides. Okay, so the
Yes,
height
sir.
is clearly we got 60, right?
Yes, sir.
Height is 60 and A, B we have to find. If it is A, then it's clear to us it is 140, right?
Yes, sir.
And for B, if it is here 30 and if it is here 80, then between 30 and 80 that difference is 50, right?
Yes, sir. 50.
140 plus 50, 190
Yes, sir.
multiplied by H, that is 60, right?
Yes, sir.
So can you calculate now? 30 into 190 because half into 60 means 30, right?
Yes, sir.
So you can calculate 30 multiplied by 190.
5,700 meters.
5,700. You got it. Okay.
Yes,
How
sir.
you got
Meter.
5,700? We can also show that one so that later on you can find it easily, right? Half,
Yes, sir.
then 140
140 plus 50
plus 50, then
into
bracket
60.
close, then multiplied by 60,
60
right? Okay, now it's done. Then the unit should be meter, right?
meters.
Clear now?
Yes, sir.
So this type of graph we can also calculate directly
Yes, sir.
using the formula of trapezium. Okay,
Yes, sir.
now we are this one is clear. Everything is almost done, right, for you.
Yes, sir.
So now we have acceleration of free fall. What is acceleration of free fall?
Objects falling downwards.
Mhm. Without air resistance,
Yes, sir. Without air resistance.
they gain acceleration if we drop any object due to the pull of earth,
Gravity.
right?
Yes, sir.
Due to the pull of earth or gravity, we get this acceleration. Okay, if we
Yes,
drop
sir.
any object, then it accelerates towards the center of earth, right?
Yes, sir.
And that is constant value, that is 10 meter per second square on earth. Clear to you?
Yes, sir.
Can you read all these points?
Uh, Constant acceleration of 10 meter per second. The above means that the speed of a downward falling object, neglecting air resistance and other forces that is not gravity/weight, will experience an increase of 10 meter per second every second. It also means that the speed of an object traveling upwards, neglect the same forces as above, will experience a constant decrease of 10 meter per second every second. In general, the faster the object travels, the greater the air resistance. When an object falls without neglecting air resistance, It experiences acceleration and an increase in velocity. This will cause air resistance acting on the object to increase as well. There will be a point where the air resistance is larger enough to balance the gravitational force. This will cause the resultant force to be zero, and there will be no acceleration. The object will reach constant velocity, which is termed as terminal velocity.
Okay, this one is a new um, term for you or new item for you, that is terminal velocity. You see the diagram. If we uh, drop any object in air resistance, then the air resistance is working upwards and the weight of the object is working downwards. If the speed of the object increases, then the air resistance also increases, right?
Yes, sir.
And once it happens that the weight of the object and the air resistance becomes equal, that time the object is no more accelerating, it's moving with constant velocity. Okay, the velocity is termed as terminal velocity. Okay,
Yes, sir.
then the final information for you, can you read it?
The magnitude of a gravitational acceleration of the Earth is determined by the mass of the Earth and not by the mass of the object. This means that a feather and a bowling ball will fall at the same rate if you neglect a resistor.
Okay, now this topic is over, right? And
Yes, sir.
I had planned that you see that almost half an hour we are done with the topic discussion, and this was my plan in last class that I would finish this topic within that 30 minutes, and after that I would give you one worksheet which one we could discuss today and we could continue another topic. Right, this was my plan, but your electricity was not working. That was a problem, right?
Yes, sir.
Net connection. This way, when you are working with Wi-Fi, right?
Yes, sir. Wi-Fi.
May I request one thing that you also keep some backup, uh,
Okay,
because
sir.
if you miss one class, then you are being far away from the completion of the course, right?
Oh, yes,
That's
sir.
why that's why please keep some backup. When the electricity will go, then you can use the mobile data the way I am doing. I always use mobile data so that I am connected always from everywhere. Okay, you only
Yes,
do
sir.
it only for backup, not always.
Okay, sir.
It will be helpful for you. Now I am giving you the worksheet in the Google Classroom. Okay.
Okay, sir.
Now I'm giving you the worksheet in Google Classroom. You check it from there. Please give me 2 or 3 minutes, okay, to upload it.
Okay.
Then you check it, and uh, when when you will receive it, you give a comment over there, right? That sir, I
Yes, sir.
got the worksheet. Thank you. This way, huh? So that I
Okay,
can
sir.
understand you saw it. Then after finishing the worksheet, now you will do the worksheet. Okay. In our
Okay,
class
sir.
time, you will do the worksheet. Once you are done with the worksheet, you send me the answer, huh? Like
Okay, sir.
before. Like before, you send me the answer. And for your test, in next class, I will give you the update of the test. Okay,
Okay,
how
sir.
much you got, or if there is any mistake, we will discuss. No problem. Okay.
Okay, sir.
Thank you so much for joining. Allah Hafiz. Huh?
Allah Hafiz.